Hi, everybody. Good morning, good afternoon, good evening. How are you? Oh, good. Look at all of us. We're here. This is so lucky of us. What a nice place to be, huh? I am so glad to be here. I haven't been here since, I haven't been to Vox Days Bucharest since 2016, right? Which is it's a long time ago. It's what is it, 6 years? No, wait, there's 2 years of pandemic. I forgot about those. So 8 years that I haven't been here. I have missed it. I'm so glad to be here. What a lovely, lovely privilege. My name is Josh Long. I was wondering, can we all take a selfie together? Yes. Is that okay? Everybody okay with that? Okay. Come on in, have a seat, relax. There's some seating, well, everywhere, really. I mean, just have a seat, be comfortable. It's going to be great. Okay, we're going to take a selfie. It's going to be hard to get all of us in one shot, so I'll take a few of them. When I say go, you say open source. What is s'mores? You say open source, smile, and then pretend to be happy, okay? Okay, ready? Okay, ready, steady, open source. And then open source. And one more time, open source. Thank you so much. I appreciate that. I really do. I'm so grateful. I'm going to take those photos and I'm going to show them to my daughter and I'm going to say, see, they listen to me. It's going to be very useful. Very useful. I appreciate that. My friends, my name is Josh Long. I work on the Spring team as a Spring developer advocate, and I'm also lucky enough to be a Kotlin Google developer expert and a Java champion. And I'm just, at the end of the day, I'm at your service. I'm so grateful to be here. I'm also a YouTuber. Cringe, I know. But there's that. I've got a YouTube and I've got email. Who's using email? Anybody use email? No, good. Moving on. I've got one of those as well. Friends, I am of the opinion that there's never been a better time to be a Java and Spring developer. Truly, never, ever have we had a better time to be a Java and Spring developer. And so today I hope to make that case to persuade you of as much in our discussion today of all the latest and greatest, or at least some of the latest and greatest, in the wild and wonderful world of Springdom. And of course, as always, friends, we're going to start our journey here on my second favorite place on the internet. My first favorite place on the internet, of course, is, anybody know? Thank you, production. I love production. You should love production. You should go as early and often as possible. Bring the kids, bring the family, bring everyone. The weather is amazing. It's the happiest place on earth. It is better than Disneyland. But if you have not been to production, you can begin your journey here at start.spring.io. Right there, if anybody wants to bookmark that. Very good. So we're going to build some new software, my friends, and we have some questions that we need to address before we can get underway. As always, some discussions that we need to have. First of all, what build tool? You can use whatever you want. I've got Maven here. What version of Spring Boot? The latest, of course. That's easy, right? And then, of course, what do we want to call our service? Friends, I'm going to call the service that we're building, I'm going to call the service Service, because I'm great with names. Amazing with names. I get that from my father. My father was amazing with names. When I was a small boy, we had a small white dog, and my father named him White Dog. That dog disappeared. I don't know what happened to him after like 10 years. He disappeared. Maybe he got a job. I don't know. But then another small white dog showed up at our family door, tap, 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 looking for a home, and we took him in, and my father named him Two. Now, I'm not sure if it's like two, like the number two, or two as in as well, Either way, great with names. I get that from my father. But my mother, she tells me all the time, she says, you're very lucky that I named you. And yeah, that's probably true. Yeah, I can only imagine what that would have been. So we're going to call it Service. Then, my friends, we have a choice of what version to use, of what version of Java. Friends, this is pretty easy here. I think you can pick Java 21 or Java 22. Those are acceptable, right? Java 17, not really a great choice anymore. It's very old. That's from 2022. Who would use this today if you could? You don't need to. You shouldn't, right? But notice, very importantly, there's no Java 8 on here. Nowhere to be found. It's not on the list. And there's a very important reason here. Java 8 is not great. We have Java 21. Java 21 is technically superior in every single way. It's technically superior. It's more robust, more secure, more operations friendly, more cloud ready. It's technically superior in every way. It's also morally superior. You won't like the look of sadness and shame in your children's eyes when they see that you're using Java 8 in production. Don't do this. Be the change that you want to see in the world. Use Java 21 or later. And as we're going to see today, Java 21 is amazing. Java 21 and later are amazing. Java 22 is amazing. So now we're going to add some support here. We want the GraalVM native image support. We want the web support. We want Postgres for SQL database support. We want the JDBC, Spring Data JDBC support. We want the, what else do we need? We want Docker Compose support or test containers. I'm going to go with Docker Compose for this. What else do we need? We could use DevTools for fast live reloads, but it's fine because it's already really fast. We can also add, it's 2024. You can't have a talk without some AI, so we'll add some OpenAI support, or Azure OpenAI Stability, or Mistral, or Azure, or Vertex for Gemini, or Llama, or Hugging Face. I'm just going to add OpenAI, okay? There we go. I think we've got a lot of our selections here. I'm very happy with those selections. Let's go ahead and hit Generate, and we're going to open this up in our IDE. I have a little script here, an alias, unzip and open, UAO. It's just an alias, okay? All it does, it is unzips the zip and opens it in IntelliJ. Now, friends, this is a data-driven application, okay? So it's going to be a public static void main, a regular Spring Boot application, and I'm going to be talking to a SQL database. So in that, on this start.spring.io, I selected Docker Compose, and I got this nice Docker Compose file generated for me automatically, okay? And I want to make sure that this is running and it's exposed so I can connect to it via pSQL or whatever on the command line. But otherwise, this is very good. Spring Boot will automatically start this up for you if you ask it to, whenever you restart the code. If you don't want that to happen, you can just disable the dependency like that, and it won't do anything, but at least you have the Docker Compose file. Oh, yeah. Are you not done yet? Okay, all right. Yeah. Who likes Java and Spring and has two thumbs? This guy, right? Okay, very good. So we've got a Docker Compose file. I've got a build. I'm going to go ahead and manually start up this Docker Compose instance. I'll say Docker Compose up, okay? Let that run in the background. And now I've got my application. I want to tell Spring Boot to talk to that application. So I'll go here. I'll say Spring data source URL JDBC : PostgreSQL localhost. And the Docker Compose file had my database secret and my user, right? So my database, and then I'll specify the password is secret. And this is just between us, okay? Don't tell anybody. My user. Now, obviously, in a production app, you'd use environment variables. You'd say something like export, and then you put that in there like this, and etc. You do that off screen and put that in a Kubernetes secret or something, okay? Okay, so there's my connection. I also want to have some initialization scripts to force it to initialize my SQL database. So I'll create a file here called schema.sql. Create table, if not exists. Customer, okay? ID, serial, primary key, and then I'm going to have name, text, not null. Very good. So there's our basic SQL schema. And we're going to create some data as well. And I'm just going to put some people that were in the Spring team. But remember, this is going to get run each time. So I'll say insert into customer, name, and I'll just put some people on the Spring team there, some names you might know from the Spring team. Madura, of course. Me, believe it or not, we've got the amazing Jurgen. Whoops, wrong one. Look at that. An American with accents. Amazing. Okay, Stefan. There we go. We've got, who else? The good Dr. Sire, one of my favorite doctors. We've got Olga. We've got Yushin. We've got Violetta. We've got, what is that, 9, 10 records plus, that's 8 total. That's a nice round number. You can divide it by 2, and then 2 again. It's still 2. It's great. I love 8. I'm a big fan. Not Java 8, though. Very important to remember that. That's the worst 8. All right, now I've got my schema. I've got all that. I want to tell Spring Boot to automatically run this SQL when the application starts up. So I'll say SQL init always, okay? Just have it run that. This is just for our demo. You wouldn't do this in a production. You'd use something like Flyway or Liquibase, which of course you can use with Spring Boot. There's selections back on start.spring.io. All right, now, friends, I've got our application here. I've got our public static void main. What I want to do is I want to build a data-centric application, okay? And so, first step, I'm going to create a record here, records, to describe my entity, okay? Now this is I love records. How many of you are using Java records here, right? I love them. I love them so much. So much. They're so good, right? These are really really amazing, amazing things. They're just so nice, okay? But here I'm just using them for a basic entity for Spring Data JDBC, but don't misunderstand. There's a lot more to records here than I am showing you, right? Records are part of a number of different features, 4 different features that were delivered in Java 21 that support what the Java team calls data-oriented programming, okay? How many of you heard about this? Data-oriented programming, okay? It's a number of things. These things were introduced earlier, some of them, and they come together. They culminate in Java 21 as this new paradigm. And the basic idea is that Java is really good in the large monolithic code base, right? By the way, monoliths are back. Have you heard this? You can go here and add the Spring modulith. Modulith, right? Spring modulith. That's a whole other talk we could do. But anyway, the point is we have a Java which has been very good in the world of the large monolithic code base. Okay? Large, sprawling code bases with lots of types. And the idea is that in these large monolithic code bases, you have deep-seated hierarchies of abstract types. And here, Java is really good. It has a strong type system, a very good and fast compiler, strong privacy controls. It really is an excellent language to build large code bases in, right? But increasingly, today, we're seeing that developers are building they're smaller, they're more network bound, they have ad hoc data coming into the services via Kafka or RabbitMQ or REST or Google protocol buffers or whatever. We're dealing with data more and more. The way that you express change in the system is not by subclassing a class anymore, not as often anyway. You do it by sending a different kind of message. And so the language has to evolve to support this new paradigm. And that's what they're talking about. And when they talk about these things, they're talking about 4 different features that come together, okay? So you have records, which we looked at briefly. You have sealed classes. You have pattern matching. And you have smart switch expressions, okay? So let's take a look at these things together. These things all support data-oriented programming. Very, very interesting new features. And so we talked about records. Well, records, first of all, this is a record. It's a Java class that has a very specific contract. It's a tuple, basically. How many of you have used another language with tuples? Tuples are basically just containers for typed data, okay? They're like an array where each element in the array can have a type. But in Java, Java is a nominal language. We say that Java has names for everything, right? Everything in Java has a name. So our tuples have a name. This tuple is called customer. If you agree with that contract, then the Java language can do amazing things for you. It can create a Java class that has a constructor, it has storage for individual fields, it has a getter method, it has equals and toString and hash code, right? It's like a data class in Kotlin or a case class in Scala, but Java, Very, very nice feature. Very, very elegant, okay? But what about these other things? Well, sealed types. The idea with sealed types is that I want to limit the number of things in a system that can implement a particular type. So let's imagine I'm working in a very heavily regulated industry, okay? Let's say I have a type called a loan for like a banking industry, right? And let's say I don't want somebody skipping the regulations, avoiding the regulations by creating an anonymous inner class of this type. Remember, loans are financial instruments. They have laws that apply to them. You need to make sure that those unit tests pass, right? And so you don't want somebody using an anonymous inner class to create that new loan. So let's say I have a secured loan, right? Class secured loan implements loan. And let's say I have another type called an unsecured loan, okay? So these are the 2 implementations. But what about if somebody goes and creates another loan called Josh's loan? 0 interest and $1 billion. You don't want that, right? You got to make sure nobody commits that and nobody gets away with it. You want the compiler to help you out here. So let's say I make this a sealed type, okay? Sealed interface that. And now it's saying, okay, well, this doesn't match, right? So I have to permit specific types, secured loan and unsecured loan, right? Okay, very good. So now I've got this, but it's saying, hey, look, these are not final and they're not sealed. Somebody else in the system could implement that. So I make them final. That way the compiler knows that there are only 2 implementations of loan in the entire code base. The compiler is guaranteeing it. This is really, really powerful. Okay, good. So now let's say I want to create a method to display a message for that, right? So class loans like this, and I'll have a display message for loan, okay? So now I've got a loan. I want to, let's say var message equals like this. And I can say, okay, if the loan instance of secured loan, then I could do SL, secured loan, and then I can downcast to that. And then I can create a message. I can say, okay, message equals, good job. Well done. Nice loan, right? That's a very friendly message from your bank. Okay, and then I have another message here. If loan instance of unsecured loan, I can say USL, unsecured loan, and I can say message equals, ouch. That interest rate is going to hurt, right? And so let's say that all the people that have secured loans have very good interest rates. It's the same for everybody. But if you have a bad loan, then your interest rate is different. So maybe this unsecured loan could actually be a class with some state in it, okay? You know what? Let's make it a record. We can say record, and we'll have a float interest. Okay, so there you go, float interest. So now I can say that loan.interest, there you go, right? I need to do this, USL, okay? So I've got now this message, very, very hostile message from my bank saying, you suck, right? This is good. Okay, so there's my code. This is a little bit verbose, isn't it? First of all, we can do pattern matching, right? You've seen pattern matching already. We've had the smart instance of operator for a while now, so we can remove this. That becomes a lot nicer, right? And then same thing down here. I can just do a smart pattern match. And now what I'm doing is I'm matching a pattern. I'm saying if this thing is castable to unsecured loan, then extract it to a variable of type unsecured loan. So within the context of this if, the USL variable is an unsecured loan. I save some extra boilerplate. Very nice, okay. But still, what happens if I don't have this case right here? Nothing. The compiler doesn't care. It doesn't know that I'm trying to make sure I cover all the use cases here. This is a big problem. And it's also very verbose. So let's see if we can switch this up and use another one of those nice features here. We looked at pattern matching, basically. Let's look at smart switch expressions. Here, I'm going to say switch the loan, okay? And here, I'm not using case statements. I'm using case expressions. I can say case unsecured loan, and I can return a variable like this, right? And I can say case secured loan and return a variable like that, return an expression like that, okay? So now, the variable message is equal to one of these two strings. It cannot be anything else, right? And in fact, I can just inline that. That's even nicer. Whoops. I can return this, voila, and get rid of that. So this is actually very nice. It's clean because I'm actually returning one of two cases. And what happens if I comment this out? If I comment this out, the compiler says, hey, you forgot to cover a case. This is not exhaustive. The compiler is making sure that I've handled all the different cases related to the two different implementations in my code. Very convenient. Thank you, Java. So if I bring this back, that's nice. But still, what about that pattern matching? Maybe I could make this code a little bit cleaner. Maybe I don't care about the unsecured loan. I just want the interest rate here, right? Well, I can extract that out with pattern matching. I can create a variable there. And in the context of this case, this is equal to that variable. I'm extracting out the components of the type. Huh? Really, really elegant. So this is actually less code, and it's safer. It gives us more while also requiring less. This is a nice place to be. Java 21 and data-oriented programming is amazing, okay? Okay, so this is all just a separate thing. I just want to point this stuff out because I think if you look at what I'm doing here, you think, oh, well, a record, okay, fine. What could that buy me? What it gives you is it gives you access to all of this. Okay? Amazing. Okay, moving on. So we have a customer record. We have an entity. Let's create a repository to deal with that. Customer repository extends a list of CRUD repository managing customer whose primary key is of type integer. Fine. And I want to create a simple HTTP controller. By the way, I have a question here, friends. Do you prefer this style, which I'm doing right now, right? I'm creating a simple controller class, right? I'm creating a Spring MVC controller class like this. Return this.repository.findAll. Okay, and I'm using @controller, @response_body. Do you prefer this style or the functional style? Router function, server response, router function return, route. Okay, get customers, and then we'll come back to this in a second, and then build customer repository. right? And then I can do request OK dot body. Server response, OK. Body, repository, find all. Find all. Repository, find all. What do you think of that? Which one is your favorite? The second style, this style, the functional style, or the controller style? The controller? Okay, controller. Okay. And then what about the functional? Interesting. So in all the other languages, which are terrible, of course, they support the functional style, right? But we have Java. I love Java, so let's just stick with that. Okay. Anyway, thank you for that. So we have now a simple HTTP controller. This will give us the data that we asked for, okay? Let's go ahead and run the program and see what that gives us. Okay, up and running. Go to localhost 8080/customers. There we go. Well, that's Safari. It does work. If you go here, come on. Look at this Google Chrome. What are you doing? Wake up. What? Embarrassing. Look at that. Okay, there. So that worked, right? It works just fine. Of course it worked. It was a demo. It was always going to work, obviously. So that's worked just fine. We have a simple HTTP application, and I'm using the servlet API here. By the way, another nice thing about Spring Boot 3.x and later, you have to use Java 17 or later, but preferably Java 21 or later, and you have to use the latest and greatest versions of Jakarta EE, which is fine. So we're using these nice types here. And you might have noticed that if you're moving to Spring Boot 3.x, you might have noticed there are some incompatibilities with the types. Don't freak out. It's easy. Just find and replace Javax with Jakarta, okay? Easy fix, basically. Just don't panic. It's okay. On our side, on the Spring team, there are people. This was actually painful for us, but on the Spring team, there are people with no hair, completely gone. They spent years making this work so that you don't have to worry about it. You just search, find and replace Jakarta. You replace Javax with Jakarta. Good stuff. So I've got now this simple HTTP endpoint, but that's all pretty, stock standard stuff. Obviously, this is old stuff. You could do this not as cleanly or as efficiently, but you could do something like this 10 years ago. And by the way, think about where we are right now in this history. I said 10 years ago. You know what happened 10 years ago? The Ice Bucket Challenge. You know what else happened? 10 years ago? Spring Boot 1.0 came out April 1st, 2014. And also, 20 years ago, we had the first version of Spring Framework. So here's Spring 1.io, History of Spring. And we released this last year to celebrate 20 years. So it's a video game. Play with your keyboard. Rod Johnson publishes the book addressing J2E complexity, right? Got Rod Johnson and Jurgen start the open source project in 2003. The first GA release of Spring Framework came out in 2004, 20 years ago. So almost 20 years exactly in just a few days. Next week, April 1st, okay? Oh, no, not April 1st. That's Spring Boot, actually. And then it happened earlier this month, actually. Was 20 years ago, right? So it's been 20 years. Spring Security 2.0, we're going down here. Got some Spring Data stuff, NoSQL, 2014. Spring Boot 1.0 in April 1st, 2014. We have Spring Boot 1.0 coming out next month. It'll be 10 years exactly. We have 2014, Spring Batch. We have the Spring integration stuff. Now we're going up into the clouds. Cloud computing, right? So you get Spring Cloud 1.0. You get Spring Cloud Task. You get Spring Cloud Stream for Kafka and RabbitMQ, Spring Cloud Dataflow 2016. Now we're going back into the water, Kubernetes, maritime themes, right? So Spring Cloud Dataflow for Kubernetes. We've got Spring Cloud Skipper. We've got Spring Cloud Gateway for Kubernetes. And of course, in 2022, 2 years ago, Spring Boot 3.x and Spring Framework 6 they give us this current generation, okay? So that's 20 years, and I hope you'll join me in celebrating that a few weeks ago and next week. It'll be 20 years and 10 years of both. So anyway, you could have done something like this 10 years ago, right? Pretty stock standard, but this is 2024. There's new stuff all the time. One of the things that people are talking about is artificial intelligence, because of course, the search for intelligence wasn't hard enough. Now we're looking for artificial intelligence. This is a problem. So let's go ahead and use that. We have this nice project called Spring AI. This is an awesome new project that we announced last year at our conference called Spring One. And we announced it, a very, very big new release, new project. And the whole point is to support all of the retrieval augmented generation pipeline, okay? So when you think about AI, don't get stressed out. A lot of people talk about AI, and then they mention Python. You don't need Python to do AI. In the same way, most people are not going to be creating their own AI. They're going to use existing AI in the same way that most people do not create their own SQL database using C, right? They use somebody else's SQL database. That's normal. So you don't need to create your own AI. You just want to integrate with existing stuff. And here, my friends, there are no better choices and no better ecosystem than Java, and in Spring in particular. As usual, we come for the enterprise, right? We're here to help. And so we have this new project, and it supports the whole retrieval augmented generation pipeline. What do I mean by that? Well, you can talk to your LLM, your large language model, your ChatGPT, basically, right, behind the scenes. You can talk to that, but that's just part of it. What if you have a bank? What if you're building an IVR, an automated assistant for your bank account system or your service, right? Well, now the user logs in and they say, okay, tell me my bank status, my bank account balance. Well, how does the LLM know? It doesn't know, right? You have to give it information to answer the questions correctly based on the current up-to-date amounts in your balance. That information you have to put in the prompt, in the text of the request itself. That's called stuffing the prompt. So how do you get that information in there, right? And also, how do you support finding related things? You do that with similarity searches. What supports a similarity search? Well, a vector database does. And there are lots of vector databases. You could even use Postgres, which has a vector database as well. And we support all of that. The process of finding data, ingesting it, putting it in the vector database, and then querying from it and integrating it with dozens of different LLMs, all of that is part of Spring AI. So we don't have time to go into all of that, but we'll talk about a simple example here, okay? Let's build a story. So we'll say @controller, @response body, and I'm going to call this storytime controller. And I'm going to inject the private final chat client, okay? I'm going to call this the singularity because, why not? And we're going to create an endpoint here called story, and I'll return just a JSON object here, story, okay? Now, come on, you can do this, Java. Go, good, okay. So first things first. So we return map.of story, and then we need a story. Well, what story? So var prompt equals, we're going to put a prompt in here, and then we'll get a reply, and we'll say this.singularity.call, and pass in the prompt, and we'll return that reply here, okay? There's that. So now here, we're going to put the prompt, and it's very important. We have nice multi-line strings. It's not just for SQL. You can do all sorts of cool stuff here. I use it for AI all the time. So it's very important, by the way, to be polite. Very important to be polite, because the machines will remember, okay? Singularity. Please, I'm so nervous. I'm talking to the LLM. Why? Please write a story about the amazing people of Bucharest, Romania. Amazing people and, wait, they're the same thing. Amazing Java and Spring developers of Romania. And please write it in the style of famed children's book author, Dr. Seuss. Now, Dr. Seuss is another one of my favorite doctors, along with Doctor Who, Dr. Strange, Dr. Subramaniam, Dr. Sire, Dr. De Volder, Dr. Pollock, and Dr. Niephaus. Okay, and then cordially, Josh. Okay, so there we go. There's my prompt. I'm going to pass it to the singularity. I'll get a response, and I'll wait for the response, and I'll return it in this map. Let's go ahead and reload that. And what do we call the endpoint here, friends? We called it story. So localhost 8080 story. And let's just wait for that to happen. I'll drink some water. Water, nice. Open source. Okay, so in Bucharest, Romania, there's a talented crew of Java and Spring developers. Oh, yes, it's true. They work day and night with code in their hands, creating applications that span many lands. Their fingers, they type so quick and so nimble. Their minds filled with algorithms that make code so simple. They debug and they test with precision and care, ensuring their programs will run without a scare. It makes poetry. It's amazing, okay? We live in an amazing time right now. Great. So now we have this. But what happened when I made that request? I asked for the response, and then I took water. I had time to kill. I could check my Instagram, right? I had a lot of time. I was waiting for that response, and that's okay. I'm not upset about that. It did an amazing thing, and it was pretty quick. You know, it's certainly faster than I could do it. If you asked me to write this, I'd come back tomorrow and it wouldn't be as good, you know? So this is really impressive. I'm not upset about the time, but what does that mean for our scalability? Huh? What happens when we do this in a large, loaded, busy service? Lots of people making requests to our server. Well, of course, this could be a problem, right? Think about how your typical web server works. You make a request, there's a servlet engine, it creates a new thread, it runs the servlet in turn calls Spring MVC, and then that in turn calls your controller handler method, and it all happens on that thread. Well, what happens when you're on that thread making this call to the AI REST APIs? Well, that REST API is doing something with input streams and output streams, right? Well, I have to wait for those bytes. I have to ask the AI for the next byte, and then I get the next byte and the next byte. I'm doing input stream.read. And while I'm doing this, I'm sitting there on the thread. I'm wasting time, right? Nobody else in the system is able to use that thread. And historically in Java, this has been a bit of a problem because threads are expensive. There's a connection between Java lang thread and operating system thread, and it's 1-to-1. But now in Java 21, the single most important feature I think they've ever added to Java, they just added in Java 21. That's why I say you should be using Java 21. It's called virtual threads. Virtual threads are amazing. Okay, let's take a look at an example here. So we're going to go back to our code here, and I'm just going to create a simple Spring Bean that runs some code when the application starts up, okay? Loom demo, okay? Return new application runner. And I stole this example. I stole it shamelessly from Jose Pomar, a professor and a Java developer advocate at Oracle, and awesome, okay? So the example is, let's create a bunch of threads like this, okay? I'm going to create a list of threads. For var I equals 0, I is less than 1,000, let's say, okay? And I'm going to add those threads. I'm going to create a new thread, equal thread dot, and we're going to do this the old-fashioned way of platform, unstarted, new runnable, okay? And I'll say threads.add thread, all right? Very good. And now, for each thread, I'm going to start the thread, and then in another loop, I'll join each thread, okay? Now, in this thread, in this runnable, what am I going to do? Well, I want to sleep, okay? I'm going to do a blocking thing. I'm sleeping. So when I say blocking thing, I mean things like input stream.read, output stream.write. These things are blocking. If you call input stream.read on a network socket and the network socket doesn't return a byte for 5 minutes, guess what? You don't get to go from line 39 to line 40. You don't get to make that move for 5 minutes. You're blocking. You're stuck waiting for the response, okay? So thread.sleep, input stream.read, output stream.write, these are blocking operations, and they keep you on the thread. Okay, so I'm going to sleep for 100 milliseconds, a tenth of a second, okay? And then after I'm done with that, I'm going to take note of the current thread name, okay? So I'm going to create a new set. Now remember, sets dedupe the element. So if you put the same element in the set 5 times, you'll only have it appear once when you iterate over it, okay? So I'll say, if I am on the first of the 1,000 threads, right, if I'm on the first one, then I'm going to add the name of the thread. So if first, names.add thread.current thread.toString, okay? Now, I'm going to do this 4 times. So I've got 100 milliseconds, and then if I am on the very first thread, I'll add the name. And then I'm going to do it again, and again, and again. So 4 times. So 400 milliseconds, I'm going to sleep on each thread, but I'm going to launch 1,000 of them at the same time. Okay, and then finally, at the end of this, I'll print out the names, like so. Okay, so let's go ahead and restart the program. And you can see, remember, we're only looking at one thread here. We've got 1,000 threads, but I'm only keeping track of the name of one of them. And this is what you would get if you did Java threading up until recently, right? I'm using platform threads. That means that I have one thread per Java lang thread and one operating system thread. Operating system threads are expensive. You cannot create an infinite amount of them. So you're limited by your scalability here. You can't create infinite threads. And the problem is that we're not making good use of the thread either, because we're wasting time blocking, waiting for the next byte. Well, there are ways around this. You could do something like non-blocking I/O. right? Non-blocking I/O is painful. What's the Romanian word for hemorrhoid? Hemorrhoid, there you go. Okay, it's painful, right? You don't want to do non-blocking I/O directly, right? So Java NIO, Java NIO2, not so fun. So my friend Trustin Lee, he's in Korea, he created a library called Netty. Netty is a nice library for doing non-blocking I/O, very powerful, right? And if you want to make that even simpler, you can use reactive programming. I like reactive programming, it's functional, I think like that, but you know what? Not everybody wants to do that. I understand. Maybe you want to take this existing code. What if there's some way to take this code and make it non-blocking? Well, now in Java 21, there is, and all you have to do is switch that. Okay? You use Project Loom, virtual threads. Okay? So now let's run the same example. All I've done is I've changed the factory method here. Here we go. Restart. And there's look at that. I'm on the same thread. I didn't change anything. I'm sleeping, and then I'm checking for the name, and I'm sleeping, and I'm checking for the name. And it looks like I've got 4 different thread names in here. So I ran the thread. I did a blocking thing. The runtime said, hey, you're sleeping for 100 milliseconds. I'm going to move you off of the thread, put you in RAM, and I'll keep a timer. And when you're done, I'll take you, and I'll put you back on another thread automatically. I didn't have to do any changes to my code. This is way better. This is amazing. Now, I get the same kind of scalability that you would get if you did reactive or async await. Don't do async await. See, we don't need that. Async await was a mistake. This is what we should have done, right? This is amazing. This is free scalability. You get it for free. You can now probably reduce, if you have a lot of I/O, you can reduce the number of computers being used to run this service in production. My suggestion to you, tell your boss you need 3 weeks to increase the scalability of your system, and ask him to put the money in your bank account that you save. All the money that you save deploying much fewer instances in cloud, you say, I want that in my bank account, in my salary, as a bonus if I do this. And he says yes, or she says yes, and you come back 3 weeks later, see, it's done. All you had to do was that, okay? Where's my check? Now, this is still very, very nice, very powerful, but it's low level. Most of us don't work with threads directly, right? I hope not. Right? How many of you know this person? Tony Hoare, right? That person, he's the person that said that he's the person that talks about the $1 billion mistake. The $1 billion mistake. He's talking about null, but he was wrong. It's PHP. Obviously, that's a fact. It's a fact. Anyway, he also talked about, and this is in the 1970s, so more than 40 plus years ago, he talked about how threading is considered dangerous, right? The way we do threading in Java, we had something like that 40 plus years ago. This is not a new abstraction, right? Although, to be fair, when Java first came out, that abstraction was only 15 years old, or whatever. But anyway, we've known for a long time. This is not how most of us want to think about threading. It's a very easy way to get yourself in trouble. Right? So most of us don't work with that low level. We use frameworks or we use abstractions like actors and sagas and whatever. But if you're using Spring MVC, you're probably not going to worry about this. And you know what? If you want to just create threads and want to override the way that the framework creates threads, you can create an executor service. So there's this new virtual thread per task executor. You can just plug in a bean of this type, and it'll automatically override the thread pool that's used by things like Spring MVC. But even better, if you're using Spring Boot 3.2, you are using Spring Boot 3.2, I hope. If you're using Spring Boot 3.2, then you just say that. And now it's done for you. You don't need to do any of that, okay? So again, talk to your manager. Say, I want to help us scale for free. Or not for free, for 3 weeks. I need 3 weeks. You can go on vacation, work on it. Okay, so we have virtual threads. We have the AI. We have our simple web service. I think, my friends, it's time to think about how do we get this thing into production, okay? I want to go to production. Production is the happiest place on earth, obviously. But how do I get this there? Well, there's first of all, the question of how do I containerize this? How do I turn it into a Docker image or an OCI image? And obviously, here, my friends, there are things like build packs. Build packs is a cloud-native computing foundation specification for taking your source code and turning it into a Docker image. You can use it with other languages if you are using other languages. Good. And if you're using Spring Boot, there's actually support in the Spring Boot Maven and Gradle plugins. So you can just go here, like this, Maven W, Spring Boot build image. Okay, it'll run that and it'll build a Docker image for you. This is a very nice technology. It answers the question, how do I reliably take my application and package it for production as a container? This is super important because remember, by the time you write a Docker file, there's already a CVE. The second you finish typing it and git commit it, there's a CVE. You've done it wrong. You're never going to do it right. This is not your job. Don't bother doing this. Let this do it for you. Friends, don't let friends write Docker files, okay? It's a waste of your time. You're not here for this, okay? Do something important, not this. So build packs are a great way to solve that problem. I'm not going to show that here because that's old. We've had that for years and years and years, but I want to remind people that it's there because it's awesome. The next question is, how do I package? How do I make my application as efficient and performant as possible? And friends, I want to remind you that Java is already very, very efficient. Have you seen this amazing, amazing blog? This blog is from 2018, before the COVID pandemic, or BC. And this blog looks at the energy use of different programming languages, okay? So you can see that C is the most efficient language, very important, for machines, not people. Very, very important we're on the same page here. It's not for people. It's definitely not. Okay, very efficient for machines. Then we have Rust. Okay, Rust, very good. Zero-cost abstractions coming in very low, 1.03. C is 1.0, very good. Okay, that's the baseline. Then we have C++. Tui, disgusting. Disgusting. Moving on. Then we have Ada, but I don't care. And then we have Java. Okay? We have Java, and Java is 1.98. That's almost 2. Let's just say 2. I'm not good at math, okay? Let's just say 2.0, okay? So Java is 2 times as inefficient as C. Is that fair? We all agree? Or C is 2 times more efficient than Java. Same thing. We're just said different ways. Okay, so we agree. So let's see what else we got here. Pascal, okay. Chapel, Lisp, okay. OCaml, Swift. If you're using iPhone and Mac and iPad and all that, and Vision Pro, whatever, you're using Swift, okay, 2.79, okay. You got Haskell and C#, fine. You got Go, Away. You've got JavaScript and TypeScript. What is going on here with these numbers? How is TypeScript 21 and JavaScript is 4.4? How is one almost 400% worse than the other? I thought one compiled into the other. This is unnatural. Now, by the way, friends, let me just be very clear. If I had the choice, I prefer strong types. TypeScript doesn't actually give you types. It just gives you kind of like a security blanket that you can hug at night. It doesn't make your code more sound, but it feels better, right? So I would use TypeScript, okay? So if you, like me, use TypeScript, then we are in the same boat. But our boat is sinking, okay? Just want to be on the same page here. So moving on. We got these these disgusting languages. The less said about which, the better. Moving on, we've got Erlang. And then, friends, we've got these two. Look at this. JRuby and Ruby. JRuby is Ruby in Java. Ruby is Ruby in C. And yet, JRuby is almost a third more efficient than Ruby. That's because the JVM is boss sauce software. It's amazing. It's amazing software. We are very lucky to be using it, okay? Just by building on the JVM, JRuby is almost a third more efficient than Ruby. And they came later, by the way. It's not like they had a lead time advantage or something. It's just an amazing piece of software. So you build on the JVM, you get benefits. And then we get Python. And this really hurts me, okay? Because I love Python. I'm a big Python user. I've been using Python since the 1990s. Bill Clinton was the president in my country when I started learning Python. right? It's like the fourth language I ever learned after C and Java and some others, right? I love Python, but still, this is 75.88. Let's round up. Let's call that 76, okay? I'm not so good at math, though, okay? But you know who is really good at math? Freaking Python. So let's go here. 76 divided by 2 is 38, right? 38. So think about that. That means that if I wrote a program in Java, and that program used energy, and that energy created carbon, and the carbon went into the atmosphere, and that carbon killed one tree. One. The same program in Python would kill 38 trees. That's a forest. That's worse than Bitcoin. Terrible. Terrible. We need to do better, okay? We need to have a conversation about this, and soon, especially with the rise of AI implementations and so on. Anyway, what were we talking about? Oh, right, Java. Java is amazing. Java is an amazing piece of software. So when I say that I want to make it more efficient and more performant, please remember, I love Java, okay? I do. I think it's just an amazing, amazing thing, but I still think we can do better. And so one of the things that you can use to make this even more efficient is to use GraalVM. How many of you have heard GraalVM? Okay, so they have, it's an open JDK distribution based on open JDK, but it has extra nice utilities. The native image compiler. The native image compiler lets you take your existing code and optimize it, right? Remember, what are the two things that I can point to that make Java so efficient, actually? If you think about your Java program, like I just showed you the energy efficiency and so on, what are the two things that make it so efficient? Because one of them is very important to understand for GraalVM. The first thing, of course, is the Java garbage collector, right? The Java programming language garbage collector is amazing. It allows me to write okay code and get away with it, right? I love the Java programming language garbage collector. That said, I don't think it's fair to say that the Java programming language garbage collector is the original Java garbage collector. I think that honor goes to this person. Her name is Jesslyn. She is from the island of Java, Indonesia, and she is a Java garbage collector. Now, friends, I love this tweet because it's from also 2018 BC. All right, look at that. Good stuff, thank you. It's from 2018 BC, and look, it's got, look at this, I love it. Sometimes the internet is mostly terrible, but this is great. Look at that, 19,000 likes. That's the number of people in the world who know about Java, programming languages, garbage collection, and Indonesia, right? All together, right here. So the internet can be good sometimes. So okay, so the Java programming language garbage collector is great, and also the just-in-time compiler. The just-in-time compiler is what allows you to take code and then deploy it in a portable way, and then at runtime have it turned into operating system and architecture-specific native code. This native code is very performant. It's the reason why a Java program can often be more performant and more scalable than something like C, because it does whole world allocation and garbage collection and native code compilation. So that just-in-time compiler is great, but it has some issues with certain dynamic elements of the program. It doesn't do very well with things like serialization, with like reflection, with, I'm doing the, there we go. Fix that up, okay? With resource loading, like if you load something from the class path, like a fav icon or something, with J and I, and with JDK proxies. These things are dynamic. They allow the Java language to load things from outside of the type system, and so they violate the type, the hermetic seal that the JIT needs to guarantee that that code will stay the same through the run of its lifetime, okay? These dynamic things they're still not a big deal. It does a pretty good job if you don't do this everywhere, right? It does a pretty good job compiling a code. So the question then is, if it does such a good job, why couldn't I take my whole program and compile it like this, proactively, instead of waiting for it to deploy to runtime and then reactively or retroactively turning into native code? What if I did it before I deployed? Well, that's what the GraalVM native image compiler does. But it still has trouble with this. These things cause issues for it. It doesn't know how to deal with these. So there is a way to fix this, right? Because remember, this kind of stuff happens everywhere. Your testing libraries, your logging libraries, your web frameworks, your ORMs, your data libraries, everything does this. So you can't get rid of it, really, right? But you can, there is a workaround. You can create JSON configuration files for GraalVM, like reflection config.json or whatever, right? But there are two problems with this JSON thing. First of all, I hate saying the word JSON. It just sounds stupid, right? I speak French. In French, you would say a JSON, which sounds cooler, okay? Much cooler. I prefer that. So, and I was in Taiwan recently. So in French, you'd say JSON, but I was in Taiwan, and there's a language, Hokkien. And Hokkien, you can say Jingsong, which means happiness, right? Either way, I prefer that to this. You know, me, I'm on team JSON. But you can do whatever you want. I think we just need to get rid of this format. It's dumb. So that's part one. That's the first problem. The second problem is that there's just a lot of configuration required. You have to write a lot of, because remember all the places where this happens. I don't have enough time to write all that configuration. I don't even have enough time to finish this talk. So we're not going to do that. Instead, we're going to use Spring Boot 3's GraalVM AOT engine, okay? So I'll go here, and I'll kick off a compilation. So Maven W, P, native, skip the tests, native compile. Okay, I'm going to go ahead and run that. There we go. And that's going to just do the work behind the scenes. It's going to use the native image compiler, which is a tool inside of the GraalVM OpenJDK distribution. The problem, of course, is that it does take a long time. And unfortunately, I now understand this famous XKCD cartoon. I love XKCD, and I understand this cartoon now. I didn't want to, but I get it. The number one excuse for not doing your work, hey, get back to work. Compiling, oh, carry on. I get this joke now. I thought this was just for the C++ people. I didn't know it was also for us. 2024 is a weird year. I get this joke now. And it is a problem. It does take a long time. I get bored. I get nervous. I sit there waiting, and I check, Instagram or X or whatever it's called now, and I just get bored, Do you ever sit there, stare at the ceiling or something? You're, looking for something to do. Maybe you have music in your head. I start humming, I hear theme songs, right? Or music from elevators. When you're in an elevator and it's just got this terrible music that keeps going forever. And I hear it in my head now, right? When I do these long compilations. And I thought, gosh, wouldn't it be great if everybody could hear elevator music as well? So I went to Oracle and I said, hey, Oracle, please play elevator music during the native image compilation process. I said, I already hear elevator music in my head while I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your amazing work. And I do. I really do appreciate their work. So I got some great responses, including this one from Andrew Din. Andrew Din is a distinguished engineer on the Red Hat Java team, OpenJDK project reviewer, a Byteman project lead, and a Graal developer. So clearly, this was a good use of his time. And he said, please, can you make it this elevator music? I'm not going to click the link because it goes to YouTube and it plays amazingly, really good music. It plays music from the Nintendo 64 video game for the James Bond movie called GoldenEye, right? So in the 1990s, there was a Nintendo 64 video game based on the movie. That video game had a soundtrack. And in the soundtrack, there's some elevator music. Perfect. Really great, okay? Really great. Then somebody else said, I would add that using beeps in general, not only for native image, really helped me to reduce development time. Yeah. That's a great idea. Why didn't I think of that? Even my stupid microwave will make a ding sound when it's done. Why can't my compiler, right? This is such a useful idea. I'm a big fan. Big fan. And then I got this response, and this response is from Dr. Fabio Niephaus. He's a researcher on the GraalVM team at Oracle Labs, a PhD graduate, and previously at Google Colab and Matan Guitars. And he says, thank you for your feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making GraalVM native images more efficient in terms of time, memory, and CPU consumption. Okay, go on. Anyway, I have prototyped the Josh Long mode. So, let's see what that is. So you click on you use the native image compiler, right? Native image Josh Long mode. And then it plays music for you. That's the whole point, right? This is a picture, but you can hear music at this point, right? In your head, like me. And it says, oh, music is brought to you by Josh Long. So you now know where this music is coming from. So you're not like, And then you're still waiting. You're still looking for something to do. Now you hear music and you're confused. You want something to look at so you don't feel so confused. And then you've got this. And I think this is going to be great, right? That's me. That's me right here, right? So yeah, so I think that's a great feature. I'm sure they'll add it to the compiler soon, okay? I'm just waiting for that merge to happen. Oh, I'm so excited about this. What were we doing? Oh, the compilation, right, yes. Oh, okay, yeah, so that finished a long time ago, actually. I got distracted. Very sad. So, okay, there you go. It took 48 seconds. Whoa. Okay, so we go to the target directory. And here's the program, du-hs service, 102 megabytes. That includes all the runtime capabilities, the library, the class path, the JRE, everything. I don't need anything else now to deploy this into a container, into an operating system. This is a Mac OS binary. So if I want to compile for Linux, I have to compile on Linux, okay? But if you're using build packs, what I showed you earlier, and you do a build image, it compiles the code inside the Docker image. So it's a Linux binary, even though you're running the compilation on Mac, okay? Okay, so I've got this binary here, 102 megs. Let's go ahead and run it. Oh, we got a problem, right? The port is already being used. So let's stop that over here. There we go, take two. There you go, there's our application. 117 thousandths of a second, 1/10 of a second. That's fine. It supports virtual threads. It supports all the stuff that we just did. But what I care about is this. This is the process identifier. Let's take that number here, and I'll go to the command line. PS-O RSS. There we go. So that's the resident set size. That's the amount of RAM. It's measured in kilobytes. So I divide by 1,000. That's 118 megabytes of RAM. Google Chrome, one tab, takes a lot more than that. Just do anything. Go to google.com, it takes more RAM than that, right? This is a great result. I have an application that now has virtual threads, scales really well, starts up in no time at all, talks to the freaking singularity, was very clean and easy to use, very nice language, integrating with everything. And it takes 118 megs of RAM. You could probably divide your server infrastructure load even further now. You probably don't, you can, again, talk to your manager. Say, I want to help. I'm going to enable these two things. My friends, we live in an amazing time. There has never, ever been a better time to be a Java and Spring developer. I hope I have persuaded you of this. Who is persuaded? Who believes? All right, wonderful. I want to thank you so much for your time. By the way, who had fun? Who had fun? Right on. Thank you so much, everybody. Have a wonderful day and a great show. Thank you for being here.